Hello everyone, today we'll continue our mini-series about debugging. Specifically, we'll be talking high level about exceptions, because they are exceptional. So obviously, in an ideal world, there will be no errors, but alas, programmers make mistakes, except me of course. But that means the program will malfunction or behave in a way that it was not intended, causing an exception from what we'd normally expect. An exception is an error. It's a signal from the software that something disrupted its normal execution. For example, if you are downloading a file from a server, but halfway through the internet goes down, that's considered an exception. The download cannot continue. The program cannot do what it was meant to do, what it would normally do under normal circumstances. The mechanism of how exceptions occur, how the execution is halted, and how control is passed to an exception handler can be quite complex, so we'll cover just the high-level beginner-friendly stuff. The entire exception mechanism revolves around two stages. First, the part of the code that fails to do something or does it incorrectly, it is said to raise or throw an exception. The second part is optional and it is called an exception handler, and it is the part of the code that receives that thrown exception. If there is no such receiver to handle your thrown exception, your program will crash with what's called an unhandled exception. So that basically means, dude, you have this error in your code and there is no one to tell me how to handle it, how to continue, so I'm just gonna crash, you know? First, let's see what this is and how it looks like. We use a method called readAllText to try and read the contents of some file, but we give it a path to a file that we are sure it doesn't exist. When we try to read the contents and put them in a variable and then display the value of that variable, let's see what happens. Boom! The program crashes with an unhandled exception, called file not found exception, because obviously that file doesn't exist. The one thing to notice here is that since we are running our program from within Visual Studio, when an exception occurs, Visual Studio will automatically pause the execution and enter debug mode. And as we saw in the previous lesson, in this mode we can hover our variable to see their values, we can see the call stack, all the stuff that can help us understand where the error occurred, what the error is, to debug practically. But again, since there is no handler for this exception, if I click continue, there is nothing to continue. The program will just crash, and this is evidentiated by the console too. We have an unhandled exception, its type is file not found exception, we have a descriptive message of what the error is, and we have the call stack that led to this exception. This is really useful, for example, if you have a client that asks for help because the application keeps crashing. You can immediately understand what happens and where just by looking at the metadata of the exception and the call stack. Though this is not how it should be handled, I'll talk about it later in this video. But for now, let's try and read and understand all this. We have an exception called file not found exception, and it has a descriptive message about the file that it tried to read and couldn't find. Then we have the call stack, and if you remember the last lesson, I said that the stack frames are placed on the call stack one on top of each other, which means the last one is the most recent and the original one from where all this started is at the bottom. So if we look at the first one, we can see program, which is the name of our file program. Then we have main, and if you remember, I explained in the previous lessons that this is the application entry point, is the function that the compiler automatically creates for you if you don't create it manually. And then we have line 1, which is exactly the line number where our application crashed. We have a single source code file and not many lines of code, but if this was a bigger project, you'd already start appreciating the fact that we can immediately see what happened and where. Anyway, let's continue. The next method in the stack is readAllText, and sure, we called a method readAllText right here. But the ones above it, validate args and open path, choose strategy core, what are those? We never called such methods, nor have we written them. When we call file.readAllText, we are actually calling code that is defined in an external library that our project references. Visual Studio set those up automatically when it created the project. We'll learn how to do that ourselves in the future, but for now, just understand that we can call code that is defined in external libraries, so we don't have to reinvent wheels and we can reuse code that others wrote before us. So for example, even when we say console.writeLine, that writeLine method needs to be defined somewhere, right? These method calls that you don't recognize are method calls inside external libraries, and from there on you are not necessarily interested in the execution path that led to the exception. Most of the times you'll be interested in what's called user code, meaning code that you've written. So you are interested where in your code the exception occurs, not necessarily where it originates in some external library. So what I want you to understand is that exceptions can occur not necessarily in your code, that they can come from external libraries, and this has two implications. First of all, even if you think you wrote the perfect program, it can still be crashed by some externally triggered exception. Second of all, when you look at the call stack and you don't recognize method names, keep looking, because further up or down the stack, you might end up in your user code, in the code that you've written. Which brings us to the next point of this lesson. If exceptions crash our programs, that's pretty nasty. How do we protect against it? Well, we can use a try-catch block like this. Is made up of two parts, the try block, where we put the code that might throw an exception, and the catch block, which catches any exceptions. So we have this X variable. It is of exception type. Don't worry about it, we haven't learned about classes yet, but we will learn in the future. For now, just assume that it's a data type, just like int. So we have a variable called X, which can be used inside the catch block. And we can access certain properties from it, like the message, which prints that descriptive message that we saw earlier on the console. And now if I run my application, I should only see the message of the exception. No call stack, no exception type, nothing of that sort. And this is how it should actually be handled. Because first of all, the user doesn't know or care about a call stack and all that. If they see a wall of text, they'll think, okay, what is this? They'll get stuck, confused, angry, they'll think of your application as a buggy piece of junk. So instead you should display a descriptive error message to them such that when they call support, they can say, look, the application said it can't find some file. And then you are wondering, maybe I have 10 places in my code where I read files. Which one of them was the one causing the error? So therefore we don't discard the call stack and exception metadata and all that. It's still valuable to us, but only for us, the programmers, not the user. So instead of displaying them in the user interface or console, we log it. We use application logs. We write it to special files that we can ask the user for, so we can inspect them and see what happened. Back to our code. You should know that there are many types of exceptions. For example, these are just a few of the most popular exceptions that you'll encounter out there. There are many others. But the idea is, exceptions are structured in a hierarchical way. So exception is the parent of all exceptions. From it, children are created that are more specialized for certain errors. From those, even more children can be specified for even more specialized errors, and so on. For example, in our case, when we tried to read the non-existent file and we got a file not found exception, the root of it was exception. From it, we had a system exception, from that an IO exception, and only from that we have a file not found exception. So 4 level of hierarchical structure until we got to our specific exception. You should teach yourself to catch as specific exceptions as possible. Why? Because when I say catch exception like this, it catches any exception. Since exception is the parent of all exceptions, it catches all. But then I don't know how to differentiate between a no reference exception and an out-of-memory exception to, for example, display customized error messages for each of them. So in our case, when we had file not found exception, if I would have said catch file not found exception, knowing that only that kind of exception can be caught in this catch block, I could, for example, try to create the file before trying to read it again. But what if we have more than one exception type we could expect? We can have more than one catch block specific for each kind of exception, something like this. And in this case, we have a file not found exception and an out-of-memory exception, each of them with customized error messages. In recent versions of .NET, we can also use pattern matching to group more than one exception type per catch block, something like this. And in this case, file not found exception and directory not found exception are children of IO exception. IO exception is a common ancestor, and because of that, IO exception catches many exceptions, and from those we just pattern match two of them, either file not found exception or directory not found exception, but this is an advanced option. Usually a generic exception catch block is placed at the end, after all the specific catch blocks, as a sort of a catch-all, a fallback, for all exceptions that were not addressed by previous catch clauses. So even if you get an exception you did not expect, you still don't get your application crashed. Also, it goes without saying, if a code inside the catch block throws an exception, even if that exception is of the same type as the exception type of the catch block, it will not be caught, because in order to catch an exception, the code needs to be placed in a try block. So you still need to handle that exception somewhere else, or you'll get your program crashed. Finally, when you get an exception, for example, let's put a breakpoint, you also need to inspect this inner exception property, because yes, exceptions can contain other exceptions, and sometimes the exception you are looking at is not the original exception. You need to expand this inner exception and look if that was not the actual cause of that exception. In this case is null, because there is no inner exception, but also again, be careful about that. Next, let's try to understand what happens when an exception is thrown inside the try block. Either you have a catch block for that exception type and is handled there, or an unhandled exception occurs and your application crashes, but in both cases the execution is immediately taken out of the try block and transferred somewhere else. Do not expect the code that follows after the line that threw the exception to be executed. So then the question arises, what if we have codes that absolutely must always be executed, regardless if we had an exception or not, like closing an open file or cleaning up memory or closing a database connection, all that. We could try to put those codes in the catch block, but what if we have more of them? Will we copy paste that cleanup code? What if the catch block itself throws an exception? What if we have no exception? We could try to put the clean codes after all the try catches, but what if we get an unhandled exception, and so on and so on. You get where this is going. So for those cases we have a finally block like this. This will be executed whether we had an exception or not, whether it was handled or unhandled or not, and all that. One peculiarity is that we can have a try block and a finally block without any catch blocks. That will not catch an exception, but it will ensure that the finally block runs in any situation. If we want to throw an exception ourselves, it's easy. We just use the throw keyword like this. Simple, right? Finally, no pun intended, what if we develop a library and many people are using it, and maybe we are internally catching an exception to log it or do something with it. But what happens with the user? Because if we catch the exception, they receive nothing. So from their perspective, something doesn't work, they don't receive an error, that's bad user experience, right? Instead, we need to catch the exception, do something with it, and throw it again, so that everyone interested in that exception can also catch it. We may try to do something like this. But both of them would be wrong. Why? Because both of them create a new exception. Even if we say throw X, don't let yourself fooled. This is not the exact same exception that originally occurred. Some data is lost, like for example the call stack. The new call stack becomes the point where we are throwing this exception, not the original call stack where the exception occurred. Instead, if we want to preserve the original exception, we need to do this. And this will preserve the original exception metadata with all the original call stack and etc. At the end of this lesson, let's address a few hot topics related to this subject. The first one, exception should be exceptional. If you have a fire alarm, you only expect it to go off when there is a fire, not when someone burns toast in the kitchen, right? In the same sense, we have users that throw exceptions when they don't find the customer in the database, or when the name text field is empty in some form. While those are logical errors, they are not exceptional. Not finding a customer in the database is a perfect business scenario. So there is nothing exceptional about it. There is no catastrophic failure. There is no violation of how the execution is expected to run. For those scenarios, we have other ways to handle it. We can return error objects, we can return numerical values that represent errors, we can return status codes and others. We will address a few of these in the future lessons, so maybe you want to subscribe to see more. Another issue to be aware of is that exceptions are slow and heavy. They used to be way slower and heavier on memory, so the situation is improved, but they are still the elephant in the room when it comes to high-performance scenarios. So if you are thinking about throwing an exception if the users of your websites try to redeem their Black Friday coupon few seconds before midnight, think again, because you might take your website down, causing a lot of exceptions to be thrown at the same time. An advice for now is to try to take a moment and go through the list of popular exception types to know which to use when. There are niche exceptions, there are rarely used ones, but there are a few that are used all the time and those you do need to learn. But don't worry, it will come with experience. For now, like, subscribe, thank you for your time and for watching, and I'll see you in the next tech frame.